So this question on financial models, 5.7 financial models. The consumer price index indicates the relative change in price over time for a fixed basket of goods and services. In general, if the rate of inflation averages or percent over n years, then the CPI after n years is the new CPI value, consumer price index, is equal to the initial consumer price index times 1 plus or over 100 parentheses to the n power. And R represents the inflation rate, N represents the period of years. I'm trying to solve for R, the inflation rate, average annual inflation, where CPI O, like initial, is the CPI index at the beginning of the year period, of the n-year period. Okay, so the first question is A, the CPI was 151.8 for 1995 and 179.3 for 2003. Assuming that inflation remained constant for this time period, determine the average annual inflation rate. Okay, so here is just an equation. I have to solve for the R, annual inflation rate. So 179.3, the new annual inflation rate, divided, the new annual consumer price index, divided by the initial consumer price index, times 1 plus R over 100 to the 8th power. Okay, so 179.3 equals 151.8 times 1 plus or over 100 to the 8th power. So I have to first try to get R by itself. The first thing I'm going to do is I'm going to divide both sides by 154.9. So I divide the left side by 154.9 and the right side. And on the right side, it just cleared out the 154.9. So I just left this fraction here equals parentheses 1 plus 1.69 over 100 parentheses to the nth power. Now I'm going to try to oh yeah, I'm solving. This is actually part B. Okay, so yeah, in this example, I'm actually solving for not for the inflation rate. I'm solving for the I'm trying to figure out, I know the inflation rate, or I'm trying to figure out, yeah, in this part down here, like after the first line. I know I already figured out the inflation rate in the other video. In this one, I'm trying to figure out what the inflation rate, how many years at the same inflation rate it would take for the consumer price index to go from 154.9 to 220. So now I'm going to solve for N. So solving for N, I have this equation down here. It's like starting here. 220 equals 154.9 times 1 plus 1.69 over 100 parentheses to the nth power. So first thing I'm going to have to do is I'm going to have to divide both sides by 154.9. So I divided both sides by 154.9, 220 over 154.9 equals parentheses 1 plus 1.69 over 100 to the parentheses to the nth power. And here now I have an exponent. I can clearly see here this is the base. All of this part here in parentheses 1 plus 1.69 over 100, that's the base. And it's being raised to the nth power. And this is giving the, like this base raised to the nth power equals this. So now I'm going to try to convert this exponential equation or function or whatever it's called into a logarithm form. So I know here, I have here y equals log a of x is equal to x equals a to the y power. So I'm just going to have to replace, move the things around. So the n over here, the n power is going to become here. It's going to become a logarithm, so it's going to be n here equals log base of 1 parentheses 1 plus 1.69 over 100 parentheses. And this would be like what usually goes in for the x in a logarithm. So like this, like right here, this base rate, like in all of this part in parentheses here, raised to the nth power equals this. That's what the form is in. Yeah. And now I'm trying to figure out what I have to raise here, the base, and what n is, what I'm raising this to give me this. And now I have a logarithm. So I'm going to have to use the change of base formula to find out what power I have to raise the base to get from here to this. So I take the natural log or the log of the x value of the log and divide that by the natural log of the base. I can either use the natural log or the log. I'm going to take the natural log of the x value and divide it by the natural log of the a value, which is the base. And that'll give me a decimal in the it'll give me a number in the calculator. In this case, it was about 21 because I'm rounding it. So that gave me the n would be 21. In this case, that means 21 years. So 21 years passed, which is what I was trying to figure out. And then I know, like, I just added to the year of the original problem that was given, like, what was it, 1995, 2003, or whenever it was. And I add that to the period I started with, and that'll give me the future time period. I'm going to show another example. This is where I worked this other one off. This example, I took a value. I knew how much in 2003 the consumer price index was 179.3, and I was trying to figure out here when the consumer price index would become 281. So I would need to solve for n. How many years would it take for it to reach that? I know r, the inflation rate, already because I solved that from the other problem. So now I'm going to have to solve for n. So 281 is similar to the one problem I just went over. 281 equals 179.3, which this is the new consumer price index equals the initial consumer price index, 179.3, times 1 plus r over 100, parentheses to the nth power. So the first thing I'm going to try to do is to get n. I'm trying to get n by itself. So I'm going to divide both sides by 179.3. So I got rid of that 179.3 on the right side now. Now I have this fraction here equals parentheses 1 plus r over 100, parentheses to the nth power. Now I have an exponent. Like, this is the base. This part here in parentheses on the right side of this equation, this is the base raised to the nth power equals x. Now I can see, like, from properties of logarithms that I have x equals a to the y power. And then I have y equals log a of x. Now I'm going to try to change this exponent into a logarithm to try to solve for n. So I'm going to have to rearrange the variables and stuff. So now I have n, it's going to have to go here in front. In accordance with, like, up here, it says x equals a to the y power and y equals log a to the x when rewritten. So the power goes over here to the side, this side of the equal sign. N equals log parentheses 1 plus r over 100. This is the base here. Log a. Y is this, in that case, y is the exponent here. Now log this is the base right here. And this, the base a, and then this value here on the right, that's the x. Now I'm trying to figure out what I have to raise the base to. Some n power to get to here, to x, the new value here. And to do that, I'm going to have to do the change of base formula. So I take the log here now. Log, or I could use natural log or log, which is like base 10, or base e, which is the ones that are available on the calculator. And I take log of here of the x value and divide it by the log of the a value. So I'm going to take log of parentheses 281 divided by 179.3 parentheses divided by log of parentheses 1 plus 2.10 over 100 parentheses. Now when I plug that into the calculator, it's gonna give me a value, in this case 21.6188, which is approximately equal to n, which is the period of years, which is what I was trying to solve. Like, what raised to the n power would equal this, and n would be the number of years. So now after doing that, I got 21.6188, which is about the number of years, which is approximately equal to n. But they want me to round it to an actual number, so it's 22. So then I had from 2003 was the year that it started with the consumer price index value I started with. And to go from here from 179.3 to 281, well, after solving for n, 22 years had passed approximately. So then it was from 2003 plus n, which is about 22, which would be 2025, which would be the time when the consumer price index would hit to 81, based upon solving for n, given the inflation rate. And in this case, I had to change it. Solve for n, I had to convert it in. I had to cancel some factors, like this factor here. That's what got me this 179.3, both sides. Then I just had to convert the exponent into a logarithm. Then I used to change the base formula to find out what power the base would have to be raised to, which was be n, to get to the x value. And n is the number of years which I needed to get from the initial time plus the number of years to get to the new time when the consumer price index would be 281. So the answer is 2025. 2003 plus the n value years equals 2025. And that's how to solve for the number of years given the inflation rate for the consumer price index.